Today, most of the things we use in our daily lives come from factories. The gas that fuels our cars, the power that lights our homes, the food and beverages we enjoy, and the medicines that treat our illnesses. All of these are created by industrial machines that mix, grind, churn, and transport to provide us with the things we need. But sooner or later, these machines break down and fail. It's up to maintenance and reliability professionals to monitor the health of their machines and perform maintenance as needed. In this video, we'll cover the different maintenance models that are used to maintain critical industrial machinery and how shifting to wireless predictive maintenance is making industrial companies more efficient than ever. But first, let's discuss the most basic maintenance model. Reactive maintenance, often referred to as run to failure. This is where maintenance is performed only after a machine fails. Although this is the most convenient option up front, it is also the most unpredictable and expensive model in the long term. Reactive maintenance comes with substantial amounts of unplanned downtime, which results in lost production and sunk operational costs. This also comes with a high risk of catastrophic failure and secondary damage, which equates to extensive repairs and replacement costs. Due to these risks, plants are required to have many spare parts in inventory and skilled maintenance personnel on hand. Lastly, by allowing severe mechanical failures to occur, it jeopardizes the safety of employees. While a run-to-failure model can be feasible for maintaining machines of very low criticality, critical machinery requires a more thoughtful maintenance approach. Preventive maintenance, or PM, is a time-based model where maintenance is performed on a recurring schedule. With PM, routine maintenance like greasing and realignment typically occur on a monthly or a quarterly basis. In comparison to the reactive model, PM can prolong equipment life cycles and provide better operational efficiency. However, it can still be a costly approach for several reasons. PM requires routine shutdowns, which can last days or even weeks, reducing the production capacity of a plant. This involves a significant recurring cost of labor to perform preventive maintenance. Further, routine maintenance is performed without knowing the condition of the machines. This results in unnecessary maintenance, which reduces the useful life of parts and equipment. This can even introduce unintended issues during unnecessary repairs. And even with preventive measures being taken, there is still a risk of machines failing in between scheduled routes, resulting in unplanned downtime and lost production. The main drawback with preventive maintenance is that it involves blindly performing maintenance and repairs without knowing the true condition of the machines. In reality, there are countless variables that need to be monitored to determine what a machine needs to operate efficiently. This is where predictive maintenance comes in. Predictive maintenance, or PDM, involves the monitoring of machine conditions to predict developing issues before they escalate. Most applications involve sensors to monitor parameters like vibration, temperature, and ultrasound. There are several variations of PDM, the first of which is manual. Manual PDM, also known as a walk-around program, requires the manual collection of sensor data from industrial machines to assess machine condition. This involves the hiring or contracting of a maintenance specialist to periodically take measurements from each machine using a data collector and provide a report about their conditions. The plant can then perform the appropriate maintenance required for each asset. While this provides periodic insight about asset health, there are several factors to consider. Manual PDM comes with a recurring cost of data collection and analysis services. This can be done internally or outsourced to a service provider. And since the data is not collected very frequently, the operating conditions of the machine can vary between data points. This leads to inconsistent data collection and erroneous conclusions. Most importantly, manual PDM does not provide a continuous indication of machine health, which leaves plants vulnerable to machine failure and unplanned downtime between data collection routes. Manual PDM is still, as the name suggests, a very manual process. Such a model is not cost-effective for large-scale production involving critical assets. In order to proactively monitor the health of machinery, a continuous PDM system is essential. These systems can either be wired or wireless. Wired PDM involves the permanent instrumentation of machinery with sensors that are wired to the plant's control room. The data is then viewable on the plant's asset management system, where plant personnel can make real-time maintenance decisions. With wired PDM, the primary cost factors come from installation. Since cables need to run from the machinery to the facility's control room, the actual wiring can be very expensive. This can be extremely complex to implement in large-sized facilities where machinery is located far apart. While a continuous wired PDM system can catch defects early on, the cost of wired PDM can only be justified for a small percentage of the most critical assets. But much like the devices in our personal lives, the industrial world is also shifting to wireless. Wireless PDM involves the permanent installation of wireless sensors on industrial machinery. The sensors continuously and consistently collect data and send it either to a local server or to the cloud. Plant personnel can access the data instantly and make real-time maintenance decisions from anywhere. This completely automates data collection. Some solutions even provide automated analytics using artificial intelligence technology. Wireless PDM typically involves an upfront cost for sensors. With the growing adoption of wireless technologies, these sensors are quickly becoming inexpensive. Wireless PDM also requires a wireless network for connectivity. But the good news is, many facilities are implementing such infrastructure to quickly launch a wireless PDM program. Finally, by continuously collecting data, it enables automated analytics to drastically reduce analysis costs. Wireless predictive maintenance can monitor the health of industrial machines in real time, helping catch defects at the onset of development. It is rapidly becoming the easiest and most affordable maintenance model to implement. Wireless PDM is being adopted by plants and facilities around the world due to the cost benefits and scalability that set it apart from walk-around and wired systems. While wireless PDM has proven to be the most beneficial maintenance model available, the most effective maintenance programs utilize a combination of models to match the criticality of their assets. It is recommended that the majority of machinery should be monitored wirelessly, with a small percentage of the most critical assets being permanently wired and machinery with very low criticality maintained with the reactive model. To put it simply, the industrial world is changing. Technological advancements like inexpensive sensing, pervasive wireless technologies, high-performance cloud computing, and advanced data science enable us to make machines smarter. Similar to modern homes, equipped with wireless smart devices, it's easy to envision a world of smart factories with real-time data from industrial machines at your fingertips. To learn more about the technology that's simplifying the industrial Internet of Things, visit petasense.com.